Hello Fortinet fans, my name is Matt Swanson and I'm with the Secure Access team at Fortinet. I'm here today to tell you about Universal Port with FortiSwitch. First, a quick rundown of the agenda. We'll have a brief discussion of what Universal Port is and how it enables simpler and more secure Ethernet networks. Then we'll dive into those solutions themselves with use cases, configuration examples, and demonstrations. Before digging into the technical aspects of Fortinet's Universal Port solutions, let's put some definition around the problem. Ensuring that users and devices that are accessing the network get appropriate network and security parameters on the port they plug into has always been a challenge, especially in dynamic environments where on-the-go users expect a consistent experience no matter where they're connecting from. It might not cause a security issue if a laptop ends up on the IP telephony network, but what if a disgruntled employee were to gain unfettered access to the R&D network? As we can see, a simple mistake or forgotten one-off configuration change can have dire consequences. FortiLink enables two different universal port solutions to solve this problem by eliminating static port configurations and putting the power of the Fortinet security fabric in control. FortiSwitch ports are configured on the fly depending on who the user is and what device they are connecting on. For folks running FortiOS 6.4 or later, Universal Port can be achieved via the integrated FortiSwitch NAC feature, and for users of FortiOS 6.2 and earlier, a FortiAuthenticator can be included to enable Universal Port. The first solution we're going to dive into is the integrated network access control feature that is built into FortiOS 6.4. With this feature enabled, devices that connect to FortiSwitch ports are interrogated by the firewall to gather information about the device. That information, such as device type and operating system, is compared against administrator-defined NAC policies, and when a policy matches the device parameters, the port gets set up automatically so that the connected device receives the correct network and security configuration. You'll see this in action during the demo when our IP phones and wireless access points get onboarded and directed to the correct network via NAC policies. Speaking of the demo, let's get going with the basic configuration of the integrated NAC solution. Okay, so I'm logged into my FortiGate, which is a FortiGate 101E running FortiOS 6.4.2. The first thing I want to do is define my VLANs. Even though I won't be assigning these VLANs to any ports, they still need to be defined in order to be referenced in any NAC policy. So I'm going to click on Wi-Fi and Switch Controller, FortiSwitch VLANs. As you can see, I already have an AP management VLAN defined here, but I need to define a new FortiVoice VLAN. So I'm going to click on Create New. First thing I'm going to do is give it a name, FortiVoice. I'll change the VLAN ID to 30. You can give it a color if you'd like. I'm going to set my IP address and subnet. And then I'm going to enable the DHCP server. Click OK. Now that I have my VLANs defined, I can navigate to FortiSwitch NAC policies and create NAC policies for FortiAPs and FortiPhones. Let's first create the FortiAP policy by clicking Create New. First, I'm going to give it the name FortiAP. You can see here that I can choose for this policy to be available to all switches or just specified switches. In this case, I'm going to specify the switch. Next, I will define the matching criteria for this policy. This policy will match if the hardware vendor is equal to Fortinet and the device family is equal to FortiAP. If those criteria match, I am going to then assign the VLAN AP management. And I'll click OK to submit this change. Now I'll create the FortiPhone NAC policy. Call it FortiPhone. Again, I'm going to specify the switch that this profile will be available for. In this case, the only matching criteria is going to be if the device family is equal to IP phone. And now, if that matches, instead of just assigning a simple VLAN, I'm going to apply some port-specific settings. So in this case, since it's a phone that may have a switch port on the back of it, I'm going to assign an LLDP profile, FortiVoice, FortiLink, to enable that switch port on the back to drop the PCs that might connect to it into the data VLAN. I'm also going to enable a voice QoS policy to make sure that voice traffic gets prioritized on the network. And finally, I'll choose a VLAN policy which contains my VLAN assignment. The final step in the process is to set the switch ports to NAC mode. To do so, I'm going to navigate over to FortiSwitch ports. I'll highlight the switch ports that I want to configure for FortiNAC. I'll right-click, change the access mode to NAC. And that's pretty much it. As you can see here, all of the ports are configured with the default VLAN as native, and they all only have the quarantine VLAN set as an allowed or tagged VLAN. All the ports are configured identically, and we're going to rely on our NAC policies to dictate settings on the port when I plug in a device. So I'm going to do that right now. I'm going to go and plug in a FortiAP to one of these ports and a FortiPhone to one of these ports in order to validate the solution. So if I highlight port 3 here, you can see now the native VLAN is FortiVoice. It shows that the LLDP profile has changed to the FortiVoice profile, and if I scroll over a little bit, I can also see that QoS profile for FortiVoice has been assigned here as well. And then on port 4, that one we just did a simple VLAN assignment for any APs that are discovered, and that one, as you can see here, has the AP management VLAN assigned. Alright, so we've seen what the integrated NAC feature can do to simplify and secure the Ethernet edge, but for users of FortiOS 6.2 and prior, we can achieve the same universal port goals with the addition of a FortiAuthenticator server. The methodology is slightly different, but we accomplish the same mission of enabling a universal port configuration and letting the network configure itself dynamically based on who the user is and what device they're connecting from, and securing that communication channel through the power of the FortiGate and Fortinet Security Fabric. Let's get started with the lab. I'm logged in here to my FortiAuthenticator. I did pre-configure a couple of things. I already have a radius relationship configured between my FortiGate and my FortiAuthenticator, and I already have my FortiPhone and FortiAP added as devices in FortiAuthenticator. So the first thing that I have to do is add my device groups. I do that under Authentication, then User Management, and User Groups. You can see here I already have a phones group created, but I do still need to create my AP group. So click on Create New. Call it APs. I'm going to choose the type as Mac. And now you'll see all of my devices that have been added to the FortiAuthenticator become available for selection. I'm going to choose my FortiAP and click OK. Alright, so after saving the group, I actually need to drill back into the group and define a couple attributes. You'll notice here when we created the group previously, we did not have this Add Attribute section, but after creating the group we do. I'm going to click on Add Attribute. These two attributes that we're going to add are going to tell the FortiGate the VLAN that this device should be dropped into, as well as the group that the user should be dropped into. So for the VLAN, I'd choose tunnel private group ID and enter the VLAN tag. Select OK. And then for the group, I'm going to select filter ID and give it the value APs. So again, this is going to tell the firewall and switch controller what VLAN to drop the user into or the device into, and then also the group that the device should belong to, and that group can be used in our firewall and security policies. After getting our devices and groups configured in FortiAuthenticator, we have a little bit of work that we need to do on the FortiGate. As I mentioned in the previous step, I already have the radius relationship set up between the FortiGate and FortiAuthenticator, but I still need to set up radius single sign-on so that my devices will do a single sign-on registration to the FortiGate in addition to authenticating to the switch port. We do this so that we can use our device groups in our firewall policies to dictate where that device traffic is allowed to flow, as well as the type of security inspection that we want to perform on devices that are members of that group. So I'm going to go over to Security Fabric, External Connectors, and click on Create New. And then I'm going to select the Radius Single Sign-On agent. I only need to make one change in here. I'm going to enable the Radius Shared Secret option and enter the shared secret that we have configured on our Radius server. Click OK to save the changes. After saving the changes, you can see the Radius connector is enabled here. I need to go into the CLI to make 2 additional changes that are not available to us in the GUI. I'll type in config user radius and then edit the RSSO agent that we just created. And there's 2 changes I need to make. The first one is to the SSO attribute. Now I'm going to change this to filter ID. This is the radius attribute that the FortiAuthenticator sends to identify the group to which the user belongs. Next, I'm going to set the RSSO endpoint attribute to username. And what this does, this will populate the firewall user table with the actual username that we've given to the device instead of just displaying the MAC address. And that's really about it. Just type end to commit the changes. Our next task is to create firewall groups that our devices will be mapped to when they authenticate. To create the groups, I navigate over to User and Authentication, User Groups, and then I'll click on Create New. I'm going to give this group a name FortiAP. And remember, these groups are being populated via Radius Single Sign-On, so I need to choose the type Radius Single Sign-On for my group. And then in the Radius attribute value, I'm going to type in that filter ID that we created previously. In this case, for the FortiAPs, my filter ID was APs. I'll click OK to save, and then I'll create a second group for my FortiPhones. Again, selecting Radius Single Sign-On as the type, and in this case, my Radius filter ID attribute is phones. Now that all of our groups have been created and mapped, I can complete the Radius configuration by pointing Radius accounting messages to the FortiGate. This is another step that needs to be completed in the CLI. And again, I'm going to type in config user radius. This time I'm going to edit my FortiAuthenticator server. Now that I'm in the FortiAuthenticator server, I'll type config accounting server, edit 1 to create a new server, set status enable, set server. This is the IP address of my FortiGate. Set secrets. And set the port. Then next. And then end to save. Now our switches will know where to send their accounting messages, which include the username and group information of our authenticating devices. The last step is to create our FortiSwitch security policy and to assign that policy to our FortiSwitch ports. So I'll navigate over to Wi-Fi and Switch Controller, FortiSwitch Security Policies, and I'm going to create a new policy. Call this policy Uniport. I'll make it Mac-based as the security mode, and I need to create a new user group that points to FortiAuthenticator. So I can create a new group right here. It's going to be of type firewall. I'm going to call it Uniport. And under remote groups, I will add our FortiAuthenticator. In this case, I'm going to say any group on FortiAuthenticator is able to use this. Select Uniport, and then the last thing we have to do is enable Mac authentication bypass within this profile. Click OK. Now that the security profile is created, I can go over to my FortiSwitch ports and add this profile to any of our ports that we want to participate. In this case, I'm going to do ports 11 through 20. So I'll select those ports. Underneath the security policy column, I'll click the little edit pencil, and now I'll select our Uniport profile, hit apply, and now that profile has been added to all of those ports. And that's it, all done. Time to test. Alright, so I've got my two devices plugged into ports 15 and 16 on the switch here. As you can see, I've got some device information showing up, and I've got the green light telling me that these switch ports are up and operational. So in order to validate that the AP and the phone that I plugged in have gotten into the correct VLAN and have gotten the correct group, I'm going to take you over to the dashboard, user and device dashboard, and then click into this firewall users. And as we can see here, I've got two devices. One of them is in the FortiAP group, one in the FortiPhones group. They both have been validated by Radius Single Sign-On. And you can see in the IP address column that my FortiAP has gotten an IP address in the AP management VLAN, and my phone has gotten an IP address in the voice VLAN. So everything looks to be working as expected. I've got my devices authenticated to those switch ports without having to make any manual adjustments. And I've also gotten group information populated for these devices so that I can use those groups in firewall policies to dictate where the traffic is allowed to go, as well as to define what security inspection I'm going to perform on devices of that group. We hope these demonstrations have given you some ideas on how to enhance security and drive out complexity at the Ethernet edge by reducing the chance for human error and providing a path to efficient internal network segmentation. Feel free to add questions to the comments. For more information, please reach out to the Fortinet Secure Access team or your local Fortinet sales team. Thanks for watching.